Welcome students to solve square root equations by graphing. So this is a whole lot like solving quadratic equations by graphing, which you've already done. So it's pretty much the same thing. Type each side of the equation into its own line in the graphing calculator. So that means like you'll have one half in one line by itself and the other half in another line by itself. And then you find where the equations intersect and the x values are the solution. So let's just try this one. So I've got my graph page here, and I'm going to type separately the square root of x minus 2 plus 3. So square root of x minus 2 plus 3, enter. Then tab, and then 3x minus 5. Enter. And you can see that there's the one intersection point right here. So then you can do menu 6, 4, start over here someplace, drag across to not be able to read that point at all. Let me try that again. So sometimes remember you may want to move these labels out of the way because they're getting in my way. Menu 6, 4 once again. Okay, so I don't know if you can see that, but the intersection point there is 3, 4, and the solution is only the x value. So my solution would be x equals 3. So remember, you may want to sketch a picture of this for yourself so you remember what to look for. But so you have your square root equation, and then I have the other one that's kind of coming through like this. Here's my solution. There's my intersection point. And the x value is my solution. So something like that. Wow. There, now that you can read that, go ahead and write that down. And if you think you're going to forget to find the intersection, you may want to do menu 6, 4. That's the command for it. Cool. All right, so simple enough. I've done it before. Now let's go down to extraneous solutions. So extraneous solutions can occur when you solve equations like the one above algebraically. So this actually happened to us on the last notes. Let's take a look at that. If you remember example 3 on the last notes, this one that we went through the trouble of solving and we got x was 13, and then we found out, oh, no, it's not. There's no solution. That didn't work. It's false. That's an extraneous solution. So it's basically, you can think of it as like a false solution. False solution. It's a false solution. And it can occur when you solve algebraically. Now it's not gonna happen when you solve by graphing. Only when you solve algebraically can these happen. So the extraneous solution, though, is what you would get if you graph the missing half of the parabola. So remember a square root. So this is x minus 2 plus 3. A square root, remember, it's just half of a parabola. There's my parabola. So you know what? I'm going to draw in the other half of the parabola. So I'm going to put this guy, I'm going to try to draw very carefully. Yeah, it's pretty good. Okay, so there's the missing half of the parabola. See that? This point right here, that is the extraneous solution. When you solve algebraically, like for instance with reverse PEMDAS like we did here, that's the solution you're finding. You're finding this solution that could be there, but it's really not there. So this right here is the extraneous solution. That's the extraneous solution, which is x equals 2.4 repeating, which I found in my calculator earlier. And then the actual solution, so this is the true solution, which is x equals 3, which we found up above. Now the way you graph this is to take your equation and just put a negative sign in front of it. It's that simple. So this one would be square root of x minus 2 plus 3 with a negative sign in front. And that's how you do it. So when something calls for the extraneous solution, that is what you're looking for. That false solution that you might have found. So the false solution that you might have found if you went through and actually worked out the problem algebraically, but that really is not a solution.